Now, after understanding the pigeonhole principle, which talks about the number needed of pigeons such that a certain circumstance is achieved with considering to the number of pigeonholes, now let's talk about a generalized pigeonhole principle. Because in the previous examples, it actually just talked about at least two of the characteristic is met. So we're talking about how many possible pigeons are there. So we had number of socks, we had number of initials, we had those number of persons in a group to have the same birthday weekday. Okay, so they talk about a certain task of at least two. Now, the generalized pigeonhole principle will also cover at least more than that. So if so, the task is, say for example, imagine the previous video, if you can still remember that, it talks about a number of initials, okay, a number how many students do we need in a school such that at least two will share the same first two initials. You can review the previous video where they have the discussion and answers to that. But what if the question would be changed into at least five of at least five students will share the same initials? In the previous one about the pairs of socks, or even the birthday, they are eight in a group. How many what do you call it? Yes, the question would be how many pigeons do we need? How many persons in a group such that they at least 10 will share the same birthday weekday. So this is where the generalized pigeonhole principle is very important. This is how it is stated. If n pigeonholes, okay, are occupied by kn plus 1. In the pigeonhole principle, it's just n plus 1, but here kn plus 1 or more pigeons, okay, where k is a positive integer. This is where it gets more generalized because we have the multiplier k. Then at least one pigeonhole is occupied by k plus 1 or more pigeon. So how do we separate this with the pigeonhole principle previously discussed? Again, it was n plus 1 here. Okay, in this point in the pigeonhole principle, it was n plus 1. And the last statement here was actually written differently. It was stated there that at least one pigeonhole is occupied by more than one. Okay, so in the previous one, it's just more than 1. But since we are now generalizing it in terms of k, which is a positive integer, okay, so we have here k plus 1 or more pigeon. So in application, we will have examples into this. The application to this, so some example is that we will be solving for basically the number of pigeons, the kn plus 1. This is what we will be solving later on. Okay, even if the statement looks like this is what we will be solving later on. And how we'll be able to solve that? We just need the value of your n, the number of pigeonholes or placements, okay, and we're going to express the target. Okay, in the previous examples it was just at least 2. Okay, that's why when you have 2 plus 1, k plus 1 equals to 2, that's why your k was 1. So in the previously discussed pigeonhole principle, that's why more than 1 was always a statement. But this time, we'll be getting the value first of the number of pigeons. So if we talk about at least 3, at least 5, at least 10, that would mean that would be our k plus 1. And with that, we can get our k, which will be substituted here together with our n to solve the number of pigeons needed. Basically, it will just ask us how many pigeons, in this case pigeons, but in those situations later on, how many of them are needed to achieve the target of having at least one of the pigeonholes be occupied by k plus 1. Okay? Again, this will be illustrated by an example later, but this is how we have generalized pigeonhole principle, which will be applicable not just for situations where we just need to look at least two, but it could even work more than that. Thank you very much for watching.